3445. In which situation is advection fog most likely to form? A. A warm, moist air mass on the windward side of mountains. B. An air mass moving inland from the coast in winter. C. A light breeze blowing colder air out to sea. The correct answer is B. Advection fog is most likely to form in the situation described in option B, an air mass moving inland from the coast in winter. Advection fog occurs when warm, moist air moves over a colder surface. In this case, as the air mass moves inland from the coast, it encounters colder land areas. The temperature difference between the warm, moist air and the colder land surface causes the air to cool and its moisture content to condense, resulting in the formation of fog. During winter, coastal areas tend to have colder temperatures, especially at night, which increases the likelihood of advection fog formation when the warmer, moist air mass moves over the colder land surface. 3446. What types of fog depend upon wind in order to exist? A. Radiation fog and ice fog. B. Steam fog and ground fog. C. Advection fog and upslope fog. The correct answer is C. Advection fog and upslope fog both depend on the movement of air, wind, in order to exist. Advection fog occurs when a warm, moist air mass moves horizontally over a colder surface. The wind carries the warm, moist air over the colder surface, causing the air to cool and the moisture to condense, resulting in the formation of fog. Upslope fog, on the other hand, occurs when moist air is forced to rise up a sloping terrain or mountain. As the air rises, it cools and reaches its dew point, leading to the formation of fog. Wind plays a crucial role in carrying the moist air up the slope or mountain, allowing the fog to develop. 3447. Low-level turbulence can occur and icing can become hazardous in which type of fog? A. Rain-induced fog. B. Upslope fog. C. Steam fog. The correct answer is C. Steam fog, also known as evaporation fog or sea smoke, occurs when cold air moves over relatively warmer water and moisture evaporates from the water's surface, creating a foggy layer. This type of fog is often associated with cold air outbreaks over bodies of water, such as lakes or oceans. Steam fog can be conducive to low-level turbulence because the temperature contrast between the cold air and warmer water can create unstable atmospheric conditions. The mixing of the different air masses can result in turbulent airflow and gusty winds near the surface. Additionally, steam fog can pose a hazard for aircraft icing. As the cold air comes into contact with the warmer water vapor, the moisture can freeze on aircraft surfaces, leading to the formation of ice. This can adversely affect the aerodynamic performance of the aircraft and increase the risk of icing-related issues. 3401. Which conditions result in the formation of frost? A. The temperature of the collecting surface is at or below freezing when small droplets of moisture fall on the surface. B. The temperature of the collecting surface is at or below the dew point of the adjacent air, and the dew point is below freezing. C. The temperature of the surrounding air is at or below freezing when small drops of moisture fall on the collecting surface. The correct answer is B. Frost forms when water vapor in the air directly transitions from a gas to a solid deposition without first becoming a liquid. This occurs when the temperature of the collecting surface, such as the ground, vegetation, or an aircraft, is below freezing and the adjacent air's dew point is also below freezing. When the temperature of the collecting surface is at or below the dew point of the adjacent air, the air becomes saturated and cannot hold as much moisture. As a result, the excess moisture in the air condenses directly onto the surface, forming ice crystals or frost. 3432. How does frost affect the lifting surfaces of an airplane on takeoff? A. Frost may prevent the airplane from becoming airborne at normal takeoff speed. B. Frost will change the camber of the wing, increasing lift during takeoff. C. Frost may cause the airplane to become airborne with a lower angle of attack at a lower indicated airspeed. The correct answer is A. Frost on the lifting surfaces of an airplane, such as the wings and tail, can have a significant impact on the aerodynamic performance of the aircraft. Frost adds weight to the wings, increases drag, and disrupts the smooth flow of air over the surfaces. These effects can reduce lift and increase the stall speed of the airplane. As a result, the presence of frost on the wings can prevent the airplane from generating sufficient lift to become airborne at the normal takeoff speed. The increased drag and reduced lift can lengthen the takeoff roll and make it more difficult for the aircraft to reach the necessary speed for takeoff. Therefore, it is crucial to ensure that the lifting surfaces of an airplane are free from frost and ice before takeoff. Proper de-icing or anti-icing procedures should be followed to remove any accumulation of frost and ensure safe and efficient flight.